So far, we've just been talking about expansion work. So work when you're changing the volume. I should point out there's many different types of work. So we can say that work, we want to calculate work. There's a bunch of different types of work. We can have expansion work. We've already done that quite a bit, talked about that quite a bit. So this is if we have expansion or compression. Other types of work would be if we had surface tension and we change the area. Let's annotate that's area. We don't use A because it can be confused with the Helmholtz function. And gamma is the surface tension. And another type of work, so this is surface work. And another type of work that's very common is electrical work. And electrical work is just going to be the potential, that's the voltage, and the change in charge. And unfortunately, we're going to use Q again, just because that's what we use for charge. So just don't confuse that with heat. And phi is the potential, or you might call it the voltage. Okay? All right, so all those are the different types of work, and just like expansion work, if we want to calculate how much work it takes to expand a surface, we would just integrate this. Or if we wanted to find out how much work it took to increase the amount of charge and move charge through a certain potential difference, we just integrate this term. So how is this related to the thermodynamic functions we've looked at? Well, we have to add those other terms. And so while we said that dg, for instance, was equal to minus SdT plus VdP, that's only true if there's no non-expansion work. So if we have non-expansion work, we have to add an extra term. So we'll just call that non-PV. And we won't specify what kind of work it is. And the same thing with the Helmholtz function. The Helmholtz function is going to be minus SdT minus PdV. But if we have non-expansion work, we're going to have to throw on that extra term as well. And you can do that with any of the thermodynamic functions, whether it's du or dH. We'll just do them all now for completeness. Remember, du is negative PdV plus TdS. And if we have non-expansion work, we have to throw that term on. Okay, this by now, these are really important equations. They're so important I suggest you memorize them. And just remember that if you have non-PV work, if you have electrical work or surface tension work or something of that nature, you throw on the expression for that onto the end. So all those are treated the same.